Hey guys, this is your Chapter 6 Lesson 1 video, and we're going to do just one video today on evaluating nth roots and using rational exponents. So that's the whole goal for today. You're going to evaluate nth roots, so not just second roots or square roots, but third roots, fourth roots, fifth roots, and study rational exponents. For an integer n greater than 1, if b to the n equals a, then b is an nth root of a. An nth root of a is written as, and you can see the little symbol there, and it's red, nth root of a, where n is called the index of the radical. If you don't see an index there, then it's understood to be 2 when we're doing square roots. Okay, real nth roots of a. Now there's two cases here. One is when we're taking an even root where our index is even, so like square roots, fourth roots, and sixth roots, and then one where n is odd, like cube roots and fifth roots and so on. So we're going to let n be an integer greater than 1. So we start with square roots and cube roots and fourth roots and fifth roots and so on. And let a be a real number. Now we're going to consider when n is even first. If a is less than 0, if you're trying to take an even root of a negative number, you're not going to have any real nth roots. Just like the square root of a negative number is imaginary, same thing with fourth roots and sixth roots, and so on. If a equals 0, then the nth root of 0 is 0. So square root of 0 is 0, fourth root of 0 is 0, and so on. If a is greater than 0, then there are technically two. There's the primary and secondary, the positive and negative nth root of a, just like there's the positive and negative square root of a. And in rational root notation, we can write it as plus or minus a to the 1 over n, or the rational exponent, rational exponent notation. Okay, so here we have the nth roots. Over here, of even roots. Over here we've got information about odd roots, so like cube roots and fifth roots. If a is negative, that's fine. Just like you can take the cube root of a negative number, you can take the fifth root of a negative number. So the nth root of a is a to the 1 over n. 0, any root of 0 is 0. So even if it's odd, cube root of 0 is 0, fifth root of 0 is 0, and so on. And then for positive values of a, there's exactly one nth root whenever we are doing odd roots. All right, we're going to find nth roots. We're going to find the indicated nth roots of a. So we have n equals 3, a equals negative 216. Anytime we're taking an odd root, we're just going to have one value. And then n equals 4, we have a equals 81. So on here, we're going to have to think about taking two values because n is even. All right, because n equals 3 is odd, and a is negative. That's what negative 216 less than 0 is trying to say to you. Negative 216 has one real cube root. Now, the cube root of negative 216, what you want to do is you want to think, what cubed is negative 216? Remember I sent you that email with squares and cubes? This is a good time to make sure you've got them memorized if you haven't done that yet. 216 is 6 cubed, so negative 216 is negative 6 cubed. Negative 6 times negative 6 is positive 36, times another negative 6 is negative 216. So negative 6 to the third power, taking the cube root of it, the cube and the cube root cancel each other out, and we just have negative 6. Let's move on to part B. Because n equals 4 is even, and a is 81, which is positive, it's greater than 0, 81 has two real fourth roots. Because 3 to the fourth equals 81, and negative 3 to the fourth equals 81, you can write plus or minus square root, plus or minus fourth root of 81 is the fourth root of plus or minus 3 to the fourth power. Fourth power, fourth root cancel, and we get plus or minus 3. Notice that if you had the symbols, just nth root of a and a to the 1 over n, those indicate the principal nth root. If you're told to find the roots in a situation like example 1, then you want both the principal and the secondary root, so you're going to list both But if you just see this symbol, if you're just told to find the fourth root of 81, it would just be 3. Or if you had 81 to the 1 over 4 power, that would just be 3. But that's the principal nth root. Thus, for even values of n, they indicate the positive nth root when you're just told to simplify and you see those symbols. A rational exponent does not have to be of the form 1 over n. It can be of the form m over n, so as long as m and n are positive integers with n greater than 1. So, let a be a real number and m and n be positive integers with n greater than 1. A to the m over n is the same thing as a to the 1 over n, all to the nth power, or the nth root of a to the nth power. And a to the m over n can also be written as a to the m power, and then the 1 over n on the outside, and you can do the nth root of a to the m. So the exponent can be inside the radical or outside the radical. A to the negative m over n, deal with the negative first. So write it as 1 over a to the m over n. And that's going to equal 1 over a to the 1 over n to the nth power, which is the nth root of a to the nth power in that denominator there. And a cannot equal 0 or else the whole thing is undefined. All right, we're going to evaluate 16 to the 3 halves and 32 to the negative 3 fifths. 16 to the 3 halves, we can write that as 16 to the 1 half cubed. 16 to the 1 half is just square root of 16, it's just 4. So we have 4 cubed, which is 64. 32 to the negative 3 fifths power is 1 over 32 to the 3 fifths power, which is the same thing as 32 to the 1/5 power, the whole thing cubed. 32 to the 1/5 power is the same thing as the 5th root of 32, and so that's 2. 2 to the 3rd power is 8, and so we have 1/8. All right, now we're going to approximate roots with a calculator. So we're going to look at 9 to the 1/5, so you're going to do 9 caret, and then in parentheses 1 divided by 5, and press enter. And there you go, it's 1.55 on and on and on. 12 to the 3/8, kind of the same thing. You're going to do 12 and then caret, parentheses 3 divided by 8, and then enter. And you get 2.539 on and on and on. And the 4th root of 7 to the 3rd power, that's the same thing as 7 to the 3/4. So it's really important that you know how to convert to rational exponents. So that's going to be 7 and then caret 3 divided by 4, and then you press enter and you get 4.3 on and on. All right, for example 4, we're going to solve the equation using nth roots. Okay, a is 4 times x to the 5th equals 128. So the first thing we're going to do is divide both sides by 4. That's going to give us x to the 5th equals 32. We're going to take the 5th root of both sides. The 5th root of x to the 5th is x. The 5th root of 32 is going to be 2 because 32 equals 2 to the 5th. Now notice we didn't have to do plus or minus when we did the 5th root. That's because 5 is an odd number. When you take the odd root, you don't have to do plus or minus. When you take an even root of both sides of an equation, you have to do plus or minus. So here we've got x minus 3 to the 4th power equals 21. Well, there's nothing to divide by. First thing we're going to do is take the 4th roots of each side. Now, because the 4th root is even, we're going to do just like we did when we have square roots. And on the number side, we're going to put plus or minus. So we're going to have x minus 3 because the 4th root of x minus 3 to the 4th power is just x minus 3. And then on the side that had just the number, we're going to put plus or minus the 4th root of 21. We're going to add 3 to each side. And so we get x equals plus or minus the 4th root of 21 plus 3. And we're going to write the solution separately. So x equals the 4th root of 21 plus 3, or x equals negative 4th root of 21 plus 3. If we want to approximate our answers, I do want to point out these are the exact answers. And if you're told to leave the answers in simplest radical form, that's the form you want to leave it in. If we want to know the approximate value, what we can do is we can use our calculator at that point and do 21 to the 1/4 power plus 3, and that's going to give us 5.14, and negative, and then parentheses, 21 to the 1/4 power plus 3, and that's going to give us 0.86. All right, our last example is from biology. A study determined that the weight, W in grams, of coral cod near Palawan Island, Philippines, can be approximated using the model W equals 0.0167 L to the 3rd power, where L is the coral cod's length in centimeters. Estimate the length of a coral cod that weighs 200 grams. So we're going to substitute that 200 in for weight, so in for W. Okay, so here's our model. W equals 0.0167 times L cubed. So we're going to substitute 200 for W. We're going to divide by 0.0167. Okay, so we get approximately 11,976 equals L cubed. So then we're going to take the cube root of each side. It's an odd root, so we don't have to worry about plus or minus. We want to have an estimate for the length, so let's use a calculator. And so we get 22.9. So a coral cod that weighs 200 grams is about 22.9, 23 centimeters long. Okay, you have everything you need to do the problems to try on your own. Please do them and come to class ready to check them and to do your rounds. Remember, if you don't understand the video well enough to do the problems to try on your own, that means you either need to re-watch the video or you need to come in and ask for clarification from me. You need to have those problems to try on your own done whenever you get to class. So if you're still a little hesitant, go to study groups during ILT, rewatch the videos, or come see me. I will see you soon. Have a good day.